Alright, on to page 519, the chapter test, which is at the bottom of the page. And it's just like all those little problems kind of crammed together down there. Alright, so we have a cube, edge is 2k, trying to find the volume and the total area. Volume is just one of those sides times itself, times itself, times itself. I gotta cube the 2 and I gotta cube the k. Can't make a k today on this thing. Alright, and total area, we talked about this before. On a cube, it's just 6 of these squares. And the squares are 2k by 2k. There's a nice k. And I gotta square the 2 and I gotta square the k. So that makes a total of 24k squared. Okay. Okay, number 2, they tell me the volume is, it was 135 and that this edge down here is 3. And I'm looking for this height here. This volume was 1/3 the area of the base times the height. So this 135 has to come from 1/3 times area of the base times the height. That's all I need to find height. This is really 3, I guess, isn't it? So 135 divided by 3, which would be 45. Yeah, I found it already. 45. Great. This one's about as straight ahead as they come. It's giving me really all I need to be able to do this. I don't really have to do anything crazy on this. So I'm saying, if you go back and look at the homework questions, I just did that video actually, so it's probably next on the list. They're way harder than this, and they're way more interesting. They're way more test-like, I think. Like this is pretty easy in terms of your plan. All right, so 64 pi times 2 essentially is what I have here. Is 128 pi. Great. In 4, I'm supposed to find the lateral area and the total area. Total area. The lateral area is 1/2 times p times l, and if we're dealing with cones, that's a circle. Perimeter of a circle is 2 pi r. And okay, I need to know this. Well, that's just Pythagorean theorem. That's not too bad. And so that's 80 pi. Total area is lateral area plus a base. Why did I cram this down here? Let's do this over here. Lateral area I just found out is 80 pi. And I have to add on a base, which here is pi r squared. 64 plus 80 is 144. Alright, they've asked me to find total area of this prism. That's lateral, and careful, yes, it's a prism, not a pyramid. Been drawing pyramids all day, and all of a sudden I gotta draw a prism. Lateral area plus 2 bases. That's perimeter times height plus 2 of these triangles. Well, perimeter's not bad. Perimeter is 13 plus 12 plus 5, which is 30. Yeah. And height I know is 20. Great. Plus 2 of these triangles, which are 1/2 times the base times the height of the triangle. Well, what's the base and the height of this triangle? Well, it turns out that 12 squared plus 5 squared is actually 13 squared, so that's a right triangle up there. So I can use 12 and 5 as my height of that triangle, height and base of that triangle, which is kind of nice. So this is 600 plus 60. 660. Yeah, see what I mean? These are a lot more straightforward than the ones you see in the homework questions. So I encourage you to watch those, especially because there's a lot of those that you wouldn't have done because the homework option you picked. All right, same prism for number 6. They just want you to find the volume. Volume here is not 1/3 base times height. It's just area base times height. Area of the base I found out already. It is 30. And the height I know is 20. Interesting, the area is the same as the perimeter on that triangle. Doesn't happen very often. Alright, again, very straightforward on this one. They want you to find the lateral area. Well, lateral area is, in a cylinder situation, is perimeter times height. Well, perimeter in a circle is 2 pi r, and height we already know, so this is 2 pi times 6 times 4. That's 24 times 2, which is 48. Like, really, that's not bad. If they gave you the lateral area and wanted you to find the radius, I mean, now we're talking, but this seems pretty easy. Find the volume. It's area of the base times the height for volume. Area of the base is pi r squared. And h, we know, pi times r squared times 4. 6 squared times 4 is not something I can do in my head, is it? Yeah, that's 144. 144 pi comes up a lot. Alright. Alright, I'm supposed to find the volume of this thing, and volume is 1/3, because we're on a pyramid, area of the base times the height, and that is going to be 1/3, area of the base isn't too bad, But I'm going to need to know height. I don't know what height is yet. Height is this thing here. Well, I'm going to use lateral area to find height, because lateral area is 1/2 P times L. Well, 60 is supposed to equal that. It's 1/2. Perimeter of the base isn't bad. It's 24 times L. So from that, I figure out that L is 5. Well, that's not exactly height, is it? Well, no. If that's 5, that's wrapped up in a right triangle situation with height, which I do need to know for this. I have 5 and height and this in a right triangle. Well, this is 3 because it's half of a length of the square, because that's a apothem and a square, and that's easy. With Pythagorean theorem magic, I find out that the height is, the height is 4. So 1/3 of 36 is 12 times 4 is 48. And that's all there is to that one. Number 10. Wow, really? I'm not even going to bother drawing this. They really just want you to do the formulas here. This is 4 pi r squared. And this is 4/3 pi r cubed. And the r is 6. They actually just give you radius. So this is 4 pi times 36, which seems like I just had to do, which is 144. And this one is 4/3 times 216, which is not as easy. That turned off. 216 divided by 3 times 4, you can do it that way, 288. Okay. Okay, this one is trying to ask us, okay, here's a little bit of a meaty question. If they're similar, this is a length, this is a length, this is a length, this is a length. If they are to be similar, and really 18 and 24 would tell me everything I would need to know about the cone in order to find things like lateral area and surface area. In other words, every cone with a radius of 18 and a slant height of 24 should be congruent. So there's no other like, oh, I don't know about the height. Well, you can find the height from these if you had to and see if it's all still similar. So the only thing we really need to find out is, do we have some sort of similar ratio going on here? Again, we have length and length, length and length. I can compare apples to apples here. I'm really trying to see, is 18 to 12 the same as 24 to 18? You can just do it this way and see if it's all true. Oh, I have a geometric mean situation going on here. Cool. All right, 18 over 12, you know what? I can just simplify that to 3/2 right now. And is that the same as, I can simplify this, and it's sure not 3/2. That would have to be 27. It reduces kind of nicely to 4/3, and no, they're not the same. So we have a no for that. Okay, good. Another similarity question. This one, you could, I don't know, could you go to the point? You could. You could go to the, oh, it says regular pyramid. It doesn't even say it's square. I made up the square here. If square, it might look something like this, but I don't know. It might not be square. I just know it's regular. It doesn't necessarily say it's square. But this kind of gives you a picture. What if they are square? I know here that if this one's 18 and this one's 6, I'm going this way. I'm going small to big like I normally like to do. K is 3. The ratio of linear stuff here is 18 to 6, which is 3. The area then, that has to compare as a k squared, which is actually 9. So these things got tripled in terms of length, so the area must have been multiplied by 9. So all I got to do is take 648 and divide that by 9 and figure out what that is. And that I can't do in my head. 648 divided by 9 is probably a nice number knowing this book. Yep, 72. Great. Okay, again here I probably didn't even need to have, I didn't have to draw them. They don't have to be things you can find lengths and widths and stuff on. We just know what the two volumes are. If I know how the volumes, if I know what the volumes are, I can compare them, and I will find the ratio of volumes, which I like to call k cubed. So if that's k cubed, I'm supposed to find ratio of area. That would be k squared. That's what I'm looking for here. So to go from k cubed to k squared, the best way to do that is actually figure out what k is, and then we'll square that. Well, that would be the cube root of this mess. But these are both nice numbers. The cube root of 1,000, you should know, is 10. And the cube root of 64, if you've seen this enough, that's 4. So this is actually 5/2. So k squared is what I'm looking for. And that's going to be k squared, which is 25 to 4. Okay. When it gives me these measurements like this, I like to draw the same base, same height. I like to draw one inside the other. Maybe that's confusing, but I think it helps, especially with the 1/3 volume thing. Yeah, so the ratio of volumes, that's easy. The volume ratio, because the volume of the cone is defined, the formula says it's 1/3 the area of the volume of the cylinder, there you go, it's 1/3. Now, this is not something, I can't like say, okay, volume ratio is 1/3, so it must be k cubed, blah, blah, blah. These are not similar objects. If a cone and a cylinder, not similar. So I can't do this k squared business. I have to actually figure out, now this, because this came from the formula, base times height and 1/3 base times height. This one, ratio of their lateral areas, I think I have to go ahead and actually figure this out. I'm not sure, but I'm guessing that's what we're going to have to do. So lateral area of the, how about the cylinder first? That is pH. That's going to be perimeter of the base, which is 2 pi times 3 times the height, which is 4, which is 24 pi. The cone, lateral area of the cone is half PL. Now, yeah, half PL. And yeah, the half and the P is all starting to look nice in comparison to this, but I get that L being a problem. So L here, if this is 3, this is 4, it looks like I'm going to have a 3, 4, 5 Pythagorean triangle. Right, so this is 15 pi. The ratio of 24 pi to 15 pi is really 24 to 15, but that reduces to 8/5. Interesting fraction. That's the ratio of areas. And that 8/5, that's not always going to be the ratio of areas or lateral areas of a cone to a cylinder. It had to do with the particulars of this one. That was the, the 3, 4, 5 right triangle, and the radius of 3, height of 4. That is only going to happen with this. This will always happen. If you have a cone inside a cylinder, the ratio of volume is always 1/3. Okay, number 15. Find the volume of a sphere. Area is 9 pi. 9 pi then is supposed to equal 4 pi r squared. If I have radius of this sphere, I can find the volume. All right, pi's cancel. Radius squared should be 9/4. So that means the radius is square root of that, which is 3/2. So I need to find the volume of this, which is 4/3 pi r cubed. Yuck. 3 cubed is 27. 2 cubed is 8. Times 4 and times 3. Some of this cancels. That'll be 9 if I cancel that and that. This makes a 2 on the bottom. Hey, that's not bad. 9/2 pi. Alright, last geometry problem in this review. Last geometry problem I'm putting on video today. It's been a long day of video making if you look at the dates all these videos were made. Okay, total area is lateral area plus 2 bases. This is perimeter times height. This is 2 times pi r squared. I know some of this stuff. Like I know perimeter is 2 pi r. I don't know height. I know this is 2 pi times 49. So altogether so far I have 14 pi h plus 98 pi. And this whole thing is supposed to equal 168 pi. I can subtract the 98 pi on both sides, and I get, looks like 70 pi. Oh, that's a nice number. Then h has to be 5. Oh, I guess I can just write that down here. H has to be 5. And again, I have a minute and a half left. What can I do? What do you want to talk about? We got like a minute and a half. No. I'm done. I think that's it. I'll see you in class reviewing for the test.